8th graders, if you guys are watching this, you are my purple group for today's lesson. You guys can see your learning targets right here. I can demonstrate how different strength and direction of forces can cause a specific change in velocity. So this is again our lesson for 2.5. You guys should have already completed the warm-up on slide 2. So what you guys see is 3 images. Each image shows a before, during the force, and an after the force for 2 different objects. So you guys can kind of see how those objects vary through the 3 pictures. And what you guys are going to do is match the key concept by clicking and dragging the key concept to the correct picture under the correct object. So your first key concept that you're looking at here, if the same strength force is exerted on 2 objects, but the objects have different masses, the object with less mass will have a greater change in velocity. Okay, key concept number 2, a stronger force can cause a greater change in velocity. And the third key concept listed here, how an object changes velocity depends on the direction of the force exerted on that object. So again, you guys can look at those before, during force, and after force and compare what's happening in these 3 images to the correct key concept. Okay, so you guys should have already completed that. And you guys should have already obviously looked on slide 3 to figure out which color group you are. If you're uncertain, you guys can right-click this link, open it up, and it'll take you guys into Amplify, and you will see that you are in fact purple group. If you're seeing a different color, wrong video, go to the correct video and watch for that group. Okay? That being said, that's all you guys need this link for, is just to check your color. Okay, so back to our assignment. If you are my purple group today, you guys are only completing slides 27 through 39. So that's the last little third of this assignment. So you guys do not have to worry about all the other slides 4 through 26. Those are for someone else to do. Okay, so you guys again are just completing slides 27 through 39. So with that being said, I'm going to go ahead and scroll down to slide 27. That is where purple group begins. So for the first part of this, or the first activity today, you guys will be doing the sim, and the sim has 2 parts to it. So really what you guys are examining here, if I go back up to your learning target, is I can demonstrate how different strength and direction of forces can cause a specific change in velocity. So again, that's really what we're looking on, is how do we basically get a certain change in velocity by exerting a certain force. Okay, so anytime it refers to the student sheet, just know that this is not a sheet you guys actually have, but it's the slides you guys have in front of you. So for part 1 of this, you guys are going to conduct a series of missions in the simulation to make objects change velocity in a specific way. So this is going to be very similar to something you guys have already done before. The challenge will be to exert a force only one time and have it cause the velocity change or after. So what direction and what strength will it be? So that's really what you guys are thinking out and collecting data on throughout all of these missions. So follow the instructions on your student sheet. Again, those are going to be in your slides, not on a sheet. Don't forget to record your data. When you finish part 1, move on to part 2. Here's your guys' link for today's sim activity, so you guys will go ahead and open that up. Okay, let's look at our next page for our part 1 directions. Okay, so for part 1, you're going to go to 2.5 Purple Explorer from the Force and Motion Sim menu. Tap on object A and record its initial velocity. So we're going to go up here, 2.5 Purple Explorer. You guys will click on A and you guys can record its velocity there. So what direction is it moving in? What's the velocity of it? Okay, remember that velocity is not just the speed, but a speed in a specific direction. So that's why when I ask you guys its velocity, I ask you guys about its direction and its speed right there. Okay, what you guys will do is press run and then prepare a force. Set up and test the force that will cause each desired change in velocity listed in the data table below. So if we look in our data table here, you guys are going to figure out how to cause these 4 changes in motion. Okay, so set up and test the force that will cause each desired velocity change listed in the data table. Each velocity change can only use 1 force, so you guys are just going to prepare and exert 1 force for each of these. Observe the object's motion. Did you cause the desired change? For that, you guys will go to Analyze to see if in fact you guys caused that desired change that you see in the data table. If you cause the desired change, record the force direction and force strength in the data table. If not, reset it and try again. So your first one that you guys will do is move 7 centimeters per second to the right. So right now it's moving 5 centimeters per second. You guys want it to speed up and move 7 centimeters per second. So you guys will hit run, then you'll hit prepare force. You'll prepare just 1 force to get it to move 7. You guys will hit exert force, and then you guys will look and say, all right, I was going 5, you should see the current being 7. Okay, because I didn't exert a force, it didn't change, didn't speed up like it's supposed to. So your current should say 7 right here. Your change should say 2. Okay. If it did that, remember you guys will record the force direction. What direction did you have to exert that force? And the force strength. Remember for force strength, you guys will look where you have that little tick mark down here under this blue line. You guys will drag it back to that tick mark. That's the point where you exerted your force. What you should see is that pink arrow with the number on it. That's your force strength. So that's what you guys would record right here in force strength. So your first goal is to get it to speed up from 5 centimeters per second to 7 centimeters per second to the right. You're going to speed up to 10 centimeters per second to the right from 5. You're going to slow it down to stop it. And you're going to reverse its direction so it's traveling 2 centimeters per second in the opposite direction. So that's part 1 of this little simulation for you guys. For part 2, again, here's your guys' link, same link you guys have been using. For this, you're going to conduct a series of missions in the Force and Motion Sim to make objects with different masses change velocity. So you're really focusing in on different mass of different objects and how you guys are going to exert different forces to get them changed in the same way. So the challenge will be to exert only one force at a time and have it cause a velocity change after. So what direction and what strength will that force be? You guys are going to examine that. Predict what will happen by responding to the questions on your student sheet, again, in your slides. Follow the directions for each test. Don't forget to record your data, and when part 2 is complete, press next and answer the reflection questions. So first of all, let's make a little prediction here. First question, if you exert the same straight force on 2 objects, one with a greater mass and the other with a lesser mass, which object will reach the target first? You guys will use your draw tool to highlight those 3 objects. And what should you do to make sure both objects reach the target at the same time? You'll answer that question there. Then you guys will go ahead and collect data. So first thing you're going to do is do 2.5 purple mission 1, 2, and 3. So if you guys click up here on your vertical bars, you can see purple mission 1. You guys have 2 different size pucks here, okay, and you're going to get them in the target at the exact same time. Okay, they are 2 different masses, so you guys have to think about how you might have to exert forces differently. You're going to have to experiment, reset a couple times to get this to happen. Select a mission and read the prompt. Press run and press prepare force. Set up the forces and test your results. Again, if it doesn't work, you guys are going to have to reset it and try it again. Use the force panel to set up the correct force, direction, and strength for object A and object B. Remember, there's the 2 little tabs after you guys hit run, where you guys can click A and B to set up your different forces. Okay, again, they're different masses, so they should be different forces that you set up. Okay, exert your force, observe your objects. Did they reach the target at the same time? If they did, they'll be sucked up by the target. Hand, press, analyze, and use the scrubber to view about force strength. Remember, you guys have your little scrubber here. Should show you the little tick mark where you guys exerted your forces. That's where you guys will see how big those little pink arrows are, what the number is assigned to those arrows. Okay, if yes, record the force direction and force strength and move on to the next mission. If not, you guys will reset it until you guys accomplish that mission. So you guys will record your data right here. Mission 1's kind of already helped. You guys can kind of see how that is different. So go ahead, test that out, see if it works, and then that should help you guys with mission 2, which looks like this. Purple mission 2. Okay, you guys can see your different masses there. And purple mission 3, again, notice your guys' different masses there. Okay, so figure out your different forces to apply to each of those. Again, you guys can kind of see how those were written there. Finally, you guys have some questions to reflect on. Here's object A has 1 mass, object B has a mass of 4. The same strength force is exerted in the same direction on each of those objects, which have different mass. So the same strength force was exerted in the same direction on both objects A and B. Why did object A go faster than object B? So explain why it would go faster. Then an object is moving to the left. In which direction would a force need to be exerted to make this object speed up? In which direction would a force need to be exerted to make it slow down? And in which direction would a force be needed to exerted to make it stop? Okay, finally, you guys have part 3 of this. You need to read this little message from Ana Gonzalez at the space station in the space agency. So what we investigated in Chapter 1 was how different size forces could change the motion of that space pod. What we found out is that there was nothing wrong with the thrusters. They thrust at a normal force each time, okay? And that was no different with chapter 2, but what we examined in chapter 2 was potentially could those little space pods have different masses. So we kind of talked about, all right, claim 1 said that that pod turned around and moved in an opposite direction. For that to happen, we'd have to have that same strength thruster force as usual, but that pod would have had to been lighter than usual to turn around and move in the opposite direction. Claim 2 said that, it just slowed down. It didn't stop like it normally does with that same strength thruster force. So what size pod would that had to have been? It would have been a heavier pod. So in that case, that heavier pod wouldn't have stopped like normal. It would have just slowed down, and eventually it would have hit the space station. What we find out in this message is the mass of the pod is 1,100 kilograms, and that's about 130 kilograms more than usual. So that kind of supports claim 2 that that pod was heavier than normal, that only the thruster force that we normally have, it wasn't broken, it just slowed the pod down. And then what we're going to see is that 1,100 kilogram space pod is going to keep moving. Eventually, it's going to hit the space station. So in chapter 3, that's really going to be our focus, is what does that collision between the space station and the pod look like? Okay, finally, moving on, do your wrap up. Do you have any questions? Circle yes or no. If you have a question, type it here. If not, you can skip that part. And then circle 4, 3, 2, 1. How do you think you did on this assignment? You guys are all done. You can forget about the rest of this assignment except for the warm up and go ahead, hand this in. I hope you guys are having a great day, and I'll talk to you soon. Bye.